Light, reflection and refraction. Lecture number 1. So, coming to the introductory part of this particular lecture, in this lecture we shall be dealing with the basic concepts of reflection and the rules behind image forming for various types of mirrors. Now, let's start with the concept of reflection of light. Reflection is a basic cause for our vision. So unless there is any reflection, we cannot see anything. For example, consider ourselves or our skin, which is visible to us only due to the reflection of light by the skin. Fine? So, to know something more about the reflection of light, we should start with the laws of reflection. This will help us understand better about the theory of reflection of light. So let's start with the laws of reflection. In all, there are just two laws of reflection, two simple ones. So coming to law number 1, it states that the incident ray, the reflected ray and the normal to the reflecting surface all lie in the same plane. Given below is the diagram illustrating the same thing. So, coming to law number 2, it states that the angle of incidence and the angle of reflection are both equal. The diagram above shows the same thing. Please have a look. Now we shall be learning about mirrors for a further understanding of what reflection actually is. Okay? So let's learn about mirrors. Mirrors are classified into two types depending on the shape. They are plane mirrors and spherical mirrors. Fine. Now let's learn something about the plane mirror. So as the name suggests, these mirrors are completely plane. They do not have any sort of curvature and hence the radius of a plane mirror is infinite. Now let's study the formation of light by plane mirrors. The formation of image of a point object O by a plane mirror is represented in the figure. The image formed I has the following characteristics. The size of the image is equal to the size of the object. The object distance and the image distance will be the same. The image formed will be vertical and erect. So when a mirror is rotated through a certain angle, then the reflected ray will rotate through twice of that angle. Okay? So let's learn about spherical mirrors. These mirrors, as their name suggests, are spherical in shape, hence they have a finite radius. Given below is a diagram of a spherical mirror. So let's learn about the sign convention. The following sign conventions are the new Cartesian sign convention. Fine. Here all the distances are measured from the pole of the mirror and the direction of incident light is taken as positive. In other words, the distance measured toward the right of the origin are positive. Similarly, the distance measured against the direction of the incident light are taken to be negative. In other words, the distance measured to the left of the origin are considered to be negative. Coming to the third point, the distance measured in the upward direction perpendicular to the PA of the mirror is taken as positive and the one below is taken to be negative. Now, let's learn about the focal length. So coming to the definition, it is the distance between the focus and the pole of the mirror. Okay, and it is represented by a small f alphabet. The focal length of a mirror is equal to half of the radius of curvature of the mirror, that is r by 2. So the straight line joining the pole and the center of curvature of a spherical mirror extended on both the sides is called as a principal axis. Note that the focal length of a concave mirror is positive and that for a convex mirror is negative. For a concave it's positive and for a convex it is negative. Now let us learn about the notations of optics. So let's start with the principal axis, where PA is the abbreviation. So PA is an imaginary line passing through the center of the mirror. If you consider the blue line to be a mirror, then the red line will be your principal axis or the PA. The next thing would be the center of curvature. It is denoted by the capital C alphabet. So it is the point on the principal axis where the light ray on passing through it and on reflection comes back undeviated. A diagram will help you understand better. Here the point C is the center of curvature. Now the third one is the focal point. It is denoted by capital F. So this one is a point on the principal axis where all the light rays meet there, whether it is a converged or a diverged one. Please have a look at the diagram again. Now, let me define the radius of curvature r. It is the perpendicular distance from the center of curvature to the mirror. Okay, and the next one would be the focal distance or the focal length, denoted by a small f alphabet. This one is a perpendicular distance between the focal point and the mirror. So given below is a diagram representing your r and f. I hope this will help you understand it a bit better. Now coming to the last definition, which is the pole of the mirror, denoted by capital P. So this one is the intersection of the principal axis and the mirror. So pole is the intersection of the principal axis and the mirror. So let's now study about the image formation by a spherical mirror. So for this there are few basic principles to be followed while tracing the image formation through a spherical mirror. So let's start with the rule number 1. This says that a ray of light parallel to the principal axis on reflection passes through the focal point. Okay, after reflection it passes through the focal point. Please have a look at the diagram. Okay, so coming to rule number 2, it says that rule number 2 says that a ray of light passing through the focal point on the reflection passes parallel to the principal axis. Okay, so a ray through the focal point on reflection passes parallel to the PA, as you can see in the diagram. Then comes the rule number 3. It says that when an object is placed on the PA beyond the center of curvature, there will be two rays, one parallel to the PA and the other through the center of curvature. So the point of intersection of these two rays will be the position of the respective image. Please have a look at the diagram. One ray goes through C and one is parallel to the PA and then it goes through F. So coming to rule number 4, it says that when the object is at the center of curvature, there will be two rays, one parallel to the PA and the other to the focus. So on reflection, the point of intersection of these two rays will again be at the center of curvature. coming to rule number 5. So in this case, we place the object between the C and the F, and you will find that the position of the image will be beyond the center of curvature, below the principal axis. So coming to rule number 6. In this case, in rule number 6, we will be placing the object on the focal point. So in this particular case, an image is never formed. Okay, please note that when you place an object at the focal point, an image is not formed, or it is formed at infinity. So coming to the second last rule, which is rule number 7. It says that when an object is placed between the pole and the focal point, which is F and the P, a virtual image is formed. That is, it is formed on the other side of the lens. Sorry, the other side of the mirror. Okay? A virtual image is formed, not a real image. Please have a look at the diagram. So coming to rule number 8, here I will be defining about the virtual and the real size, and the virtual image and the real image. So here the side of the mirror from where the incident ray arrives is called as the real side, and the other side of the mirror is called as a virtual side. So if the image is formed on the real side, it is called as a real image, and if at all the image is formed on the virtual side, it is called as a virtual image. Now let's know what object distance is. So this one is denoted by a small u alphabet, and it is the distance between the pole and the position of the object on the principal axis. Now let's study about the image distance. This one is denoted as V, and it is the distance between the pole and the position of the image on the principal axis. Okay. So given below is the diagram showing the image distance and the object distance, where U is the object distance and V is the image distance from the pole. Okay. Now let's come to the mirror formula. So this is actually a mathematical approach to estimate the position of the image or the object, provided we have some parameters. So if at all we know either of the two of the three parameters, which are the focal length, the image distance and the object distance, then the unknown quantity can be figured out with the following formula. So the formula is called as a mirror formula, and it is denoted by 1 by F equal to 1 by U plus 1 by V. This is your mirror formula. Please remember this one. So the continuation will be in the next lecture, where we will be solving some problems on this particular concept. Okay. Thank you for watching.